Assalamu alaikum everyone. Today we will learn how to solve problem 3.7 to 3.10 Dynamics Unit Number 3 Class 9th. Here's the problem statement of 3.7. The two masses 26 kg and 24 kg are attached to the end of a string which passes over a frictionless pulley. 26 kg is lying over a smooth horizontal table. 24 kg is the mass moving vertically downward, and we have to find the tension in the string and the acceleration in the bodies. So let's see the scenario of this problem. In this problem, as we can see, there are two masses. The first is 26 kg and the second one is 24 kg. 26 kg is lying over the smooth horizontal table, but 24 kg is moving vertically downward. So in this figure, the M2 is equals to 26 kilograms, while the M1 is equals to 24 kilograms. To calculate the acceleration in these bodies, we use the formula A is equals to M1 divided by M1 plus M2 multiplied by G, the gravitational acceleration. And to calculate the tension within the string, we have to use this formula M1 M2 divided by M1 plus M2 multiplied by G. So to calculate the tension in the string, we use M1 is equals to 24 kgs multiplied by M2, that is equals to 26 kg, divided by 24 plus 26, the whole multiplied with the gravitational acceleration, whose value is 10 meters per second square. The value of the tension is equals to 124.8 Newton. To calculate the acceleration in the bodies, A is equals to M1 divided by M1 plus M2, then whole multiplied with the gravitational acceleration. So M1 is equals to 24 kg divided by 24 plus 26 and multiplied by 10 meters per second square. So acceleration in these bodies is equals to 4.8 meters per second square. Let's see the problem 3.8. How much time is required to change 22 Newton second momentum by a force of 20 Newton? The related topic of this problem is force and the momentum. And what this topic says, it tells us about when a force acts on a body, it produces an acceleration in the body. F is equals to ma and will be equal to the rate of change of momentum of the body. So force is equals to the rate of change of momentum. First we have enlist the given data. Here the change in momentum was given to us. So change in momentum is equals to 22 Newton second. This change in momentum is produced by the force F, which is equals to 20 Newton. So PF, final momentum minus the initial momentum divided by time, this is the change in momentum, divided by time, is equals to the applied force. By putting the value 22 Newton seconds divided by time is equals to 20 Newton. Time is equals to 22 Newton seconds divided by 20 Newton, and the time 1.1 second required to change 22 Newton second momentum by a force of 20 Newton. Let's see the problem 3.9. How much force of friction between a wooden block of mass 5 kg and the horizontal marble floor? The coefficient of friction between the wood and the marble is 0.6. Let's see the scenario of this problem. Here the two surfaces in contact is magnified here to show you how the friction forces act. Here the ups and downs in the surface is called the cold welds. The point of contact between the two surfaces form a sort of cold weld. These cold welds resist the surface from sliding over each other. Adding weight over the upper block increases the force pressing the surface together and hence increases the sliding resistance. So if the weight of the object is higher, the sliding friction will also be higher. To calculate the force of friction, we use the formula Fs, the force of static friction, is equals to the coefficient of friction mu s, static friction, the coefficient of static friction, multiplied by R. R is the reaction force. The reaction force is equals to the weight of the object, and which is equals to m into g. So in the given data, the mass of the block is given, that is equals to the 5 kg. So weight of the object should be equal to 5 multiplied by 10. G is the gravitational acceleration, 10 meters per second square, and now it is equals to 50 Newton. So the weight of the object is 50 Newton, and the reaction force is also equals to W, which is equals to 50 Newton. Mu s, the coefficient of friction, was given to us is equal to 0.6 between the wooden block and the marble floor. By putting the value, we will get the value of static friction mu s into R, 0.6 multiplied by 50 Newton is equal to the force of static friction is equal to 30 Newton. Now let's see the problem 3.10. How much centripetal force is needed to make a body of mass 0.5 kg to move in a circle of radius 50 cm with a speed of 3 meters per second? Okay, here is a roller coaster car. In the coaster car moves around the loop, the track provides centripetal force preventing them to move away from the circle. So here you can see the coaster car try to move in a straight line due to its inertia, but the track will provide it the necessary centripetal force to move around the circle. Mass of the body is equals to 0.5 kg. Radius r is equals to 50 centimeter. Centimeter is not the SI units. The SI units of length is meter. So convert the centimeter into the meter is equals to 50 centimeter divided by 100. .5 meter. The velocity of the object is equals to 3 meters per second. Now centripetal force Fc is equals to mv square divided by r. 0.5 kg multiplied by 3 meters per second square divided by 0.5 meter. 9 Newton. 9 Newton is the centripetal force which is required to move 0.5 kg of mass into a radius of 50 centimeter with the velocity of 3 meters per second. That's all about today's problems. If you really understand these problems, then like my video, share my video with your friends and subscribe my channel. Thank you very much.